6x squared times x would be 6x cubed. And then 6x squared times negative 2 would be negative 12x squared. Now we need our first terms to cancel out, so we're going to multiply both of these by a negative. So we just changed the signs of what we wrote. So our 6x cubes cancel out, and then we add our negative 19x squared plus 12x squared, which gives us negative 7x squared. And now we need to do it again. We need to see what times x gives us 7x squared. So what times x gives us this negative 7x squared?
7x.
Negative 7x.
Negative 7x, yeah.
So now we multiply that negative 7x that we wrote on top to both terms in the front. So we have negative 7x squared, and then negative 7x times negative 2 would be a positive 14x. And now we need to combine them so they cancel out. So before we combine them, we have to change the sign. So this negative 7x becomes a positive, and the plus 14 becomes a negative. So it's super important that we change the signs in this step so we get our 7x squareds to cancel out. And then we combine these two together. So 16x minus 14x gives us 2x. And now we need to see what times x would give us 2x. What times x gives us 2x?
2.
2. So we have a plus 2. And now we multiply what's on top by what's out front. So 2 times x would be 2x, and 2 times negative 2 is negative 4. Now we change the signs. So this becomes minus, our 4 becomes a plus. Add these two together. So our 2x's cancel out. And then we have negative 4 plus 4, which is just 0. And then once we run out of numbers at the top, we're done. So here our remainder would be 0. So when we divide, our answer is what's on top. So if you guys notice here, all of the terms with the same variable line up. So we have all of the x squareds on top of each other. We have all of our x's on top of each other. And then all of our constants on top of each other. So all of our terms are going to line up. So any questions about long division? And now we're going to move on to synthetic division. We have one more slide about long division. So here, the important part is if the remainder of f of x is 0, then our divisor divides evenly into f of x. So in the last one, we had a remainder of 0. So our divisor, what we were dividing into it, our x minus 2, goes in evenly. So this is pretty much the case for any division. If your remainder is 0, it goes in evenly. Also important to note here that the degree of the divisor has to be less than or equal to the degree of the dividend. So in that last one, the degree of our divisor was 1, because we just had x minus 2, so our degree for the x was 1. And then our degree of the dividend was 3. So we're able to divide because our divisor was less than. Okay, now we move on to synthetic division. So synthetic division is almost like a shortcut when you're dividing polynomials. It's a quick trick on how to divide without using long division. So here, when we have our vertical pattern, so when we go up and down, we are adding the two terms together. When we go diagonally, we multiply by the front, which this will make sense when we do the examples. And then also, the number that we put out front, this k, we have to switch the signs for, like, it's going to be x minus a number, and then we have to make it a positive number when we put it out front. So if we have x minus some number, we make it a positive. If we had x plus some number, we make it a negative. So we always have to change the sign of that number. So for example 4, we are going to use synthetic division to divide. So this number here is going to be our number that we put out front, but we have to change the sign. So out front, we're going to put a negative 3. And then inside the box, we put all of our coefficients that we have. Again, just like when we're long division, we need to make sure that we have all the terms starting with our first degree and then going down. So if we have x to the 4th power, we need an x to the cubed power. So what we would do here is just add in a 0x cubed. So we need to make sure we have all terms, starting with the highest one that we're given, and then just going down. So if we have x to the 4, we need x to the 3, x to the 2, x, and our constant. So now we're going to write all of our coefficients in the box. What would our coefficient for our x to the 4th power be?
-1.
X to the 4th power. This one. We don't change the sign of what we put in the box. So what would our coefficient be?
1.
1. What would our coefficient for x cubed be, our next number that we put in the box?
1.
So our x cubed, we had to create it.
-10, right?
We're looking at our x cubed, so x to the 3rd power. It would be 0.
Oh. Oh, because you have to do it by order.
Right, we have to do it in order. Next we have x squared, so that would be our -10. And then we have -2, and then 4. So first thing we do is drop down our first coefficient. So we drop down this 1. Then once we have a number outside, we multiply that by the number out front here. So we have 1 times -3, which would be -3. We add the numbers on the inside. So 0 plus a -3 would be -3. Again, we multiply what's on the bottom with what's out front. So -3 times -3 would be 9. We add the insides. -10 plus 9 is -1. Multiply. 3. Add 1. And then multiply. And we get -3. And then add. And we have 1. So now, I always like to start with the thing farthest to the right and then just go up. So our last number here is going to be our remainder. Then the next number is our constant. Then the next number is our x. Then the next number is our x squared. And then the next is our x cubed. So I just always like to start with the bottom and then work my way up. So here, when we divide, we get x cubed minus 3x squared minus 1x, which we don't have to put the 1, so it would just be minus x plus 1. And then our remainder is 1. Another way we could write the remainder, if we had x cubed minus 3x squared minus x plus 1, we could write our remainder, whatever number that is, over our divisor. So that would be x plus 3. So these are just two ways of writing the answer. So you could either write it this way with remainder 1, or you could see it this way with your remainder over the divisor. So these are the same. So I'm just going to show you guys that we can do long division and get the same answer. So we would put our x plus 3 on the outside. And then inside we put x plus 4, or x to the 4th power. We need to include our 0x to the cube power because we have to make sure every term is represented. And then negative 10x squared minus 2x plus 4. Okay, so what times x gives us x to the 4th power? Anybody? What times x gives us x to the 4th power?
X cubed.
X cubed.
X cubed.
Awesome. So we're going to write our x cubed over the x cubed because we want to keep all of our terms in line. So then we multiply what's on top with what's out front. So x cubed times x gives us x to the 4th. X cubed times 3 gives us 3x cubed. Then we have to change the signs because we want these to cancel out. Our x to the 4th cancels out, and then 0x cubed minus 3x cubed would just be negative 3x cubed. What times x gives us negative 3x cubed?
Negative 3x squared.
Perfect, negative 3x squared. Now we multiply the top with what's out front. So we have negative 3x cubed. Negative 3x squared times 3 would be negative 9x squared. We need to change the signs so we get them to cancel out. And then we combine our x squareds together. So we have negative 10x squared plus 9. This would give us a negative x squared. What times x gives us negative x squared?
Negative x.
Negative x, perfect. Then we multiply the top with the front. We have negative x squared minus 3x. Change the signs. Combine. Negative 2x plus 3 would just give us a positive x. What times x gives us x? 1.
Yeah.
So we multiply with the top and the front. So we have x plus 3. Change the signs. Our x's cancel out. 4 minus 3 gives us 1. And that 1 is our remainder. So did we get the same answer?
Yeah.
Yep. So using long division or synthetic division, we get the same answer. Personally, I think synthetic division's easier, but on the quiz that you guys have, you'll have to do one using long division and one using synthetic division. We have the remainder and factor theorems. So our remainder theorem just states that we can evaluate our polynomial f of x when x is equal to k by dividing that number, and the remainder would be what f of k is. So this will make so much more sense when we see it on the next one. But the important part here is that to evaluate a polynomial, when x is equal to some number, we would divide our function by x minus that number, and whatever our remainder is will be our f of that number. So for this example, it's asking us to evaluate when x is equal to -2. So what we could do, which we've done this in the past, is just take that -2 and plug it into all the x's in our equation and find out what f of -2 is. Or we could do synthetic division, and we would divide by x minus -2. And whatever our remainder is, that's what f of -2 is. So let's do synthetic division. We put our -2 on the outside, and then we put all of our coefficients inside the box. So we start with an x cubed. We need to make sure we have all of our terms here. So if we start with an x cubed, we have an x squared, we have an x, and we have a constant. So we don't need to add anything. So we're just going to put our coefficients inside the box. What do we do with our first coefficient?
We bring it down.
Bring it down. What do we do next?
You time
Multiply.
times it should be -6.
So we get -6. Then what do we do?
2 would be 8 minus 6. Then -4. Then 1. Then -2. Then -9.
Awesome. So this last term is our remainder, and we know that by the remainder theorem, that number that we get for our remainder, if we plugged in f of -2, we would get -9. So if we plugged in -2 into all of our x's here, we would get -9. So let's plug in -2 just to prove that we did it. So we have 3 times -2 cubed plus 8 times -2 squared plus 5 times -2 minus 7. -2 cubed would be -8, and -8 times 3 is -24. -2 squared is 4. 4 times 8 is 32. 5 times -2 is -10, and then minus 7. So 24 plus 32 would be 8. 8 minus 10 minus 7. 8 minus 10 would be -2. And -2 minus 7 is -9. So we get the same answer. So we can evaluate x is equal to -2 just by doing synthetic division. We don't have to plug it in. We just divide by x minus -2, and whatever our remainder is what we would get if we plugged it in. if our remainder was 0, then that would mean that the number that we plugged in would be a factor of our function. All right, the next slide. Next we have our factor theorem. So we can test whether a polynomial has x minus that number as a factor by evaluating the polynomial at x is equal to that number. If our answer is 0, then x minus that number is a factor. All right, and let's look at the next example. So this tells us, show that negative x minus 2 and x plus 3 are factors. So we can show that these are factors two ways. We could plug in 2 and negative 3, and if we plug in 2 and get 0, then we know that x minus 2 would be a factor. If we plug in negative 3 and get 0, then we would know that x plus 3 is a factor. So we could plug them in, or we could use our remainder theorem and just divide synthetically. So we're going to divide. So we take, remember we have to change our sign, so we take a positive 2 and put it on the outside. And then we need to write all of our coefficients on the inside. We have an x to the 4th power, we have an x cubed, x squared, x, and our constant. So we don't need to add anything. So we're just going to write all of our coefficients on the inside of our box. What do we do with our first term? That 2 inside box?
Bring it down.
Bring it down. So then we multiply. 2 times 2 is 4. We add, multiply, add, multiply, add, multiply, add. So if we get 0 as our remainder, that means that that number that we plugged in is a factor. So yes, this is a factor. So what is our new function that we have once we just divided that negative 2?
2x cubed plus 11x squared plus 18x, then plus 9.
Perfect. So now we're going to see if x plus 3 is a factor of this new function that we have. So we are going to divide by negative 3. So what are we going to put inside of our box?
2, 11, 18, and 9.
Awesome.
Yeah.
So now we bring this down. We multiply and then add, multiply, then add, and then multiply and add. So we got 0 again as our remainder. So what does that tell us about negative 3? Or x plus 3?
Yeah, it's like yes.
Yes, what?
Yes. It's like a factor.
Yes, it's a factor. Sorry, my computer is going to die, so I just need to plug it in. All right, so now that we divided x minus 2 and x plus 3, how can we find the remaining factors? What are we left with here after we just divided both of these?
You're just left with x squared and, well, 2x squared, 5x plus 3.
Perfect. And now we can just factor this. We know how to factor this. We would multiply our first and our last terms together, and we get 6. What are two factors of 6 that add and give us 5?
3 and 2.
3 and 2. So now we put those into our parentheses. We have x plus 3 and x plus 2. Since our coefficient out front is not 1, we need to divide both of these by that coefficient. If it goes in pretty, we simplify it. So 2 divided by 2 would be 1. So we have x plus 1. If it does not go into a pretty number, we bring it out front. So this would be 2x plus 3. And then to find our zeros, we just set both of these parentheses equal to 0 and solve for x. So we would get x is equal to negative 3 over 2, and x is equal to negative 1. So our other two factors here would be, which we could leave it like this actually. It depends on how it asks, but we could leave it like this or we could write it like this. So how many factors in total do we have?
Just be 2.
But how many did we start out with?
3.
4. Oh yeah, 4.
4. We have 4. And remember we said yesterday that the highest exponent tells us how many factors we're going to have. So since this is x to the 4th power, we have 4 factors here. So it gave us 2 that we just had to show and prove. So we have x minus 2 is a factor, x plus 3 is a factor, and then 2x plus 3 is a factor, and x plus 1 is a factor. Any questions here? Okay, this next slide is kind of like a summary of everything that we just did. So the remainder obtained in synthetic division of a polynomial gives us the following information. So the remainder tells us the value of f at x is equal to k. So k is just some number. So that remainder would be the function if we plugged in that number. So this is what we did in example 5. If our remainder is equal to 0, then we know that x minus k is a factor of f of x. So this is what we did in example 6. And then if our remainder is equal to 0, then k0 is an x-intercept of the graph of f. So what we've been doing this whole time, every time you guys find the zeros, you change y to equal to 0, you find the factors of your function. So this is pretty much just saying the same thing. When y is equal to 0, those are your x-intercepts. So the numbers that you find, those factors are your x-intercepts. So x-intercept is when y is equal to 0, and it crosses the graph at the x-axis.